Aloha, Rich Alverson here. This is ITS128. It's October 22nd. And we're going to continue, I think, chapter 6, the chapter on functions. So let me do as I always do and share my screen. Okay, here we are. Okay, so let's, we're in this is the class that we're in. If we go down and we are around, this is October 26th. So we're in here, the rest of chapter 6. All right, so let's go here first. I don't recall doing any of the labs. So let me go to resources and let me go to this thing and see what labs are there. Let me open up the textbook too. And for chapter 6, we've got driving costs, convert to binary, and swapping variables in Fibonacci sequence, I guess. We've got driving costs, convert to binary, swapping so there are videos for all of them. Okay, so you can look at the video first. You can look at the video first, and if there's a problem with the video, see, some of these videos are pretty old, fall 2021, and so if they are not clear in some way, or it could even be wrong. There's a couple of them that are wrong, if I recall. You just let me know, and I'll make a new one. But in the meantime, let's continue on with chapter 6, scope of variables and functions. Okay, in this chapter, okay, so we're going to talk about scope, and what scope is. It has to do with when you declare a variable or you're using a variable, where is it valid? Because you've got, you have these functions, and there's like variables inside the functions, and then there's variables outside the functions. And like if you have the name of a variable inside a function, it's the same as the name of a variable outside a function. Is it the same variable or is it a different variable? Well, it depends. And so that's what we're going to talk about today. That's what we're going to start by talking about. And so here, for example, we've got a variable out here called centimeters per inch, and that's a value. We have a variable out here called inches per foot, and that's a value. And then here we're going to convert, I guess we're going to convert these two numbers into a centimeters number. So the way we do it is, first of all, we're going to compute the total inches, and then we're going to compute the centimeters from that. So, and so we see here inches per foot and centimeters per inch. So these are variables. We're using these variables inside this function, but they are defined out here. So does that matter? Let's see. Okay, so local variable scope extends from the assignment to the end of the function. Global variable scope extends to the end of the file. So this looks like a global variable. The function's variables, this and this. So all this is saying is that the variables inside here, this one and this one, can only be used inside here. It can't be used outside. Once this function is done, in other words, okay, so you call this function wherever you call it. Looks like you call it here, and then it starts up, uses this variable, or assigns this variable, writes, returns this variable, and that's it. When it's done, it goes back to continuing on here, and but the actual instances of these variables disappear. I mean, so that frees up space, and if there's another function that's called, then some of that space may be used for the new function. So So a variable defined outside a function is called a global variable, and global variables extend all the way to the end of the file. A global statement must be used to change the value of a global variable inside a function. So here we have we have a variable name out here, and then in here we've got a function called get name, and it asks the person at the keyboard to type in an employee name, and that gets stored in here, and then so that's this, and that gets stored in employee name, and then the function ends. Well, this does not get assigned. This is different than this. See, and so we might want this to be the same as this. If we want this to be the same as this, then first of all, we do like we do. We declare it out here. We start using it out here. But then inside here, we say this. We say global employee name. What that means is that we're going to use the variable employee name, down below here, and we mean the employee name that's defined outside this function. So that's this one. So now when this works, it'll actually print out the correct employee name. So here, in this example here, where we do not use the global, we enter the employee name, and someone enters that name, and then when we print it out here, it's nothing. It's the same as it is here because this didn't work anyway. So and here it works, you see. All right. So the global function must be applied. Okay. Function definitions must be evaluated before that function is called. What that means is that you need to define the function before you use the function. It's not true in all languages, but in this one, it's true. Makes total sense. So make sure you do that. All right, namespaces and scope resolution. Okay, this talks about more or less the process of resolving the differences. Print global namespace globals. Okay, so this is you're able to print the global namespace. Here, there's no globals. And then we do something like this, or we do something like this, we do something like this, and now there's one global, which is this one. And all this means is that it's defined in the main program. See, this is the main program because it's not inside of a def. This is not inside of a def. Here's the first def, and so this is inside the main program. Anyway, so here, so first there's no globals. Then when it comes down to here, there's only one global. That's this one. So that's why we have this one, just that. But then once we define this function, that makes another. That's another global because the function is an object. You remember that from the last week. So now we have a global, another global, which is that one, and it happens to be a function. So now when this prints, we got two globals. We got this one and we got this one. That's what this is. We got that one and that one. Here that talks a little bit about there's built-in stuff, like these things. These are functions. We use them all the time. We've been using them since the beginning. This one, we've been using this one since the beginning, and we didn't identify them as functions back then because, I guess they wanted to wait until they presented chapter 6 before they talked about functions, and then we can go back and say, oh yeah, by the way, all these things that we have been using, they're also functions. And okay, so this is the name. These are the names defined outside the function, and local is inside the function. The process of searching for a name in the available namespaces is scope resolution. So it starts, we're inside a function. It starts inside the function to see if it can find the where that variable happened to be defined, and then if it doesn't find it, it goes outside this. It goes outside the function. All right, so maps the visible names in a scope to objects. That must be this. Oh, right. Maps. Okay. Scope resolution. This one. And then the area of code where a name is visible. It's a namespace. Returns a dictionary of names, so that must be. Oh, is that this one? Oh, okay, wow. Maps the visible names in a scope to objects. Okay, anyway, all right. Terminology. Terminology is good to learn because terminology can be quite different from language to language. All right, where are some, let's find some challenges here. See, we are in section 614. Let's go back here and see. It's so small. So 614, there's some challenges in here. Okay, this is function arguments. You know what arguments are? They are they are variables, they are values that you're passing, that you pass to a function for the function to use to calculate or do whatever it's going to do. Arguments to functions are passed by object reference. When a function is called, new local variables are created in the function's local namespace, binding the names in the parameter list to the passed arguments. So that's called, there's different ways that you can pass arguments to functions, and you can either just pass the values, or you can pass the well, let's say you have a variable called I, and the value of a variable I is 5. And if you want to pass I to a function, you can either pass the location of I, so that means the function can change I because the function knows where I is, or you can just pass the value of I, and that's generally safer because if you just pass the value to a function, then the value can do with it whatever it wants, and it doesn't affect outside the function. So the value stays the same. So here we have a function which it's just called birthday, and it takes it's inside the function here. This is called that age thing. That's called a parameter. Outside the function, here's where we call the function. This thing is called an argument. So an argument always has a value, and the parameter generally has a value also. Okay, so here we are defining Timmy's age, which is 7, and then we're going to call this function called birthday, and we're going to send it Timmy's age, which is 7. And then it goes and does it, and it takes whatever that came in, which is the 7, and it adds 1 to it. So now age is equal to 8. Okay. Now, when we come back out here and we actually print this, it's going to print 7, because changing this, which changes this, did not change this outside here. Let's make sure that's right, because it's different in different cases. So here we have a function called so we execute this first thing because it's the first thing that comes along, and we define this object called birthday. It's a function, and then we create a variable called Timmy age, and we store 7 into there, And then when we call birthday, birthday is called, and that's the point we are right now. This thing is about to be executed, and age equals 7. So age points to this value here, and then let's go see what's next. Okay, then age is incremented by 1. So now age, we have a new value here, 8, and age is equal to that. And then when we come back out here and actually execute that, Timmy's age is still 7. Timmy's age is still 7, and this thing disappeared. So the point is that when this thing is called and executed, it creates a new variable called age internal to this function, and it assigns, it assigns whatever this was when it came in. So it was 7 when it came in, assigns it to 7, does something to it. Doesn't matter when this function's over, age disappears, and when you come back down here, we didn't return age or anything. We didn't do anything with age. We just took it in, added 1 to it, and that's it. We didn't do anything with it. So that's why it's kind of gone. That's why we don't see it over here. All right, now let's do some challenges. Okay, so current balance and receipt amount are read from input. So we have current balance and receipt. I'm going to turn off this thing. See what happens. Nothing. So we have so first this executes, which all it does is it creates an object, names it estimate balance, and stores whatever the contents of the object is, which is a bunch of statements. And so that's what that does. And then it creates, and then it asks the user for an input, takes it, creates it to a floating point number, and stores that in current balance. So that's created. Receipt amount is created. And what we're supposed to do is put code here to make it so what? Outputs the where's total cost? What is this? Figure out and outputs the difference of balance on card and total cost. Okay, so we're buying something. We're buying something that's got a total cost. We're supposed to call our current balance.
It's different.
Huh?
It's different.
Are we supposed to see amount are read from input? Current balance or see the read from estimate balance has got 2 parameters on 2 parameters, that one and that one. And outputs the difference. Where does it get total cost? I don't get where it gets total cost. Okay, so what I'm going to do is I'm going to open up my other version of this textbook and figure out the answer, figure out what it says is the answer. So I got to do this and it's over here. Okay. Zybooks. You can see what I'm doing, can't you? Okay, fine. And sign in. And this is my teacher version. And we are doing this class. We are in chapter 6. And we are doing this section. And we are down here. It's probably going to be a little different. But good thing about this one is I got the solution. Huh? This different. Yeah. Yeah. Okay, so let's try this one. Phrase list is read from input. Shift left has one parameter list to modify. And shifts list to modify left. Call shift left with a copy of the list phrase list as the argument. All right, this I don't get this. Okay, I'm sorry. I should have looked at it before I came, but it's too complicated for me to figure out right now. So I'm just going to look at the solution. What does that do? Here we talk about that, don't we? All right, I should have gone over this too. Okay, because we talk about immutable and mutable, which is what I was talking about earlier about, okay, if it's immutable, then it can't be changed. If it's immutable, it can be changed. Okay, so semantics of passing object references as arguments is important because modifying an argument that is referenced elsewhere in the program may cause side effects outside the scope of the function. So when a function modifies a parameter, whether or not that modification is seen outside the scope depends on the mutability of the object. When a function modifies a parameter, that means you're passing in a variable into a function, and the function is going to take that variable and it's going to modify it. Now, is that outside of this? So then the function completes, and then we're outside the function again. Is that variable? Does that variable stay modified like what the function did to it, or does the variable stay how it was before it was passed to the function? If it's immutable, that means it can't be mutate. It means it can't mutate it. That means it can't change. So if it's immutable, then it is limited. The modification is limited to inside the function. In other words, the function can go ahead and modify it all at once, but it's not going to affect, when the function's done, it's going to go back to what it was. If it's mutable, it means it can mutate. Means it's like the coronavirus, it could change, and then so the function changes it, and then when the function's over, it stays changed. So all right, so lists are mutable and strings are not mutable. Yeah, strings are not mutable. Strings are immutable, but strings are immutable. It means you can't change strings, but you can change a list. Okay, so let's see what this does. Let's just run this. Okay, so we're going to start. This is the first line to execute this because it executes down here. First, it's going to create this. It executed that, and it created this is the global frame. It created a object called modify, and that object happens to be a function. So this is what it creates. Okay, what's the next step? Then it executes my list, and it creates this list. Looks like that. And now we're about ready to execute, and the next line to execute is this thing. So now we're going to go next, and we're going to modify list. And so now this is a list. So in here it's called num list, modify num list, and num list is just points to that list. So it passes in the so-called address of the list. It doesn't take the whole list and pass that in. If it took the whole list and passed it in, then that would be like immutable, because you pass the whole list in there and you go, okay, function, here's the list. Do with it what you want. I don't care. When you're done, my list is not going to change. But if it's mutable, which is a list is mutable, then when you pass it to the function, it's going to, and if it changes it, then when the function is done, it still is changed. Okay, so now it executed. Okay, so now it's calling this function. We just executed this line, which calls this, and now it's going to go up here and it's actually going to execute this function before we just sort of initialized it. Now we're calling it to execute it, and what happens is it executes this thing. It goes to this line, and what this does is this changes the second element of the list. The first element is 0, is the 0th element. 1 would be the second element. It makes it 99. So that's the 20. It's gonna make this thing here 99. In here, it's gonna make it 99. So let's execute it. And so there it executes, and now we see it executed it, and so now there's 99 there. And now it's done, but it didn't modify anything. I mean, it didn't return anything because it's done, and there was no return statement, so it doesn't return anything. Well, that's great because there wouldn't be any place to put it anyway. You see this modify function is there all by itself. It's not on the right side of an, there's no equal sign, there's no variable on the left side. So this just executes, it returns nothing. And so now the list looks like this. However, when we go back here and we print the list, the 99 is printed because when we modified it up here, we modified it up there, it actually changed the list itself, the original list. So done in. So sometimes the programmer needs to pass a mutable object to a function, but wants to make sure that the function does not modify the object at all. Okay, so you have this list, you want to pass it to a function, but you don't want the function to mess with it. You just want to pass it to the function for information. And the function, now no. You can make your function so it takes the list that it was passed, creates a copy of it, and then messes with the copy. The function could do that, but let's say the function does not do that. Let's say the function just takes the list and just messes with it. And you want to avoid that from happening. So you can call it this way. Put the, and okay, so sometimes, okay, one method to avoid unwanted changes is to pass a copy of the object as the argument, like in the statement this. Okay, this passes a copy of it, and if I think about it long enough, I can probably, if you think about it long enough, it probably makes sense that this is, of course, this will just pass a copy, but I'm not going to go through that mental exercise right now. Just know that if you do it this way, you're passing the list. You're passing the list itself. You're passing like the address of the list. It's like and here you're passing a copy of it. So and so if we go through this exercise here, first it does that, and then next time here we're calling it, and then here we execute that. We're about to execute that. Lo and behold, we execute it. Got that there, but you see but it's doing it to a copy. It's doing it to a copy called num list. Whereas before my list was the original list itself. I guess num list num list was the same as my list. In this case, num list is the same as my list, but in this case, num list is different. So that's why we have two of them. This is why this is my list here, but num list was a copy. So when that's created, comes down here and prints it, and it's just going to print. It's going to print the same. It's going to print what it was. So anyway, I hope that makes sense. Okay, let's go back down to this now. In fact, I wonder if we should go to this one. I still don't understand this one. Let's do this other one. Let's do the one I just was looking at. Okay, so the answer we see is this shift left phrase. Okay, so here we're just passing. So we want to call shift left. Call shift left with a copy of the list. With a copy of this list. Call shift left with a copy of this list as the argument to avoid modifying this list. Okay, well then yes, that would be then just shift left. Is that what that is? Shift left a copy of a copy of this. So that would just be, you put that there, and then you do a left square bracket, a colon, and a right square bracket. And that will do it. And I got that one right, I hope. Now, I still would like to get this one done, working. Current balance, 2 parameters. Okay, so I don't want to modify current balance. I guess I'm supposed to, okay, so I'm going to just guess. I'm going to call estimate balance, and I'm supposed to make, I'm not supposed to modify current balance. Okay, so, okay, this is a credit card, right? And this is the balance on your credit card. And then this is something you're buying. And so this thing is going to take what you're buying and subtract it from the balance on your card, and what's left is going to be how much is on your card. So that's what this is supposed to do. So the current balance must be balance on card. So I'm going to say current balance. And I'm going to do this square bracket colon square bracket thingy that they just told us about. And then I'm going to say that receipt amount must be the total cost. So I'm going to say that receipt amount. And we don't have to worry about it messing with receipt amount because it doesn't mess with receipt amount. Oh, it doesn't mess with balance on card either. All it does is print that out. Oh, wait, what? Oh, wait. We want uh, I don't understand this problem. Let's see what I got here. All right, what did I do wrong? Oh, well, I got to write something out. So if the input, if the current balance is this, and the thing you're buying is this, then the predicted balance is going to be this, but then it does output the current balance. So it outputs the current balance. It outputs the first one. Okay, so all right, so what am I supposed to do here? Hmm. Gee, I don't know this one. I can't get this one. What happens if I go over here and I refresh this? Ah, do you know what I'm missing here? I'm missing something. See, this prints out predicted balance. This prints out the current balance. And here I send it the current balance and I send it the receipt amount, which is the total cost, and it prints out the predicted balance. First, it prints out the predicted balance, then it prints out the current balance. First, it prints out the predicted balance, and then it prints out the current balance. And mine didn't produce any output.
Was and sorry, it's no no currency and crown is not it it's not I think it removed current is not
Is not, huh?
yeah.
It's not, take this off? Yeah, all right, sure. That probably works. Why didn't print it? Probably because it was an error. Oh, there was an error. It probably pointed, it was pointing out an error to me, wasn't it? Okay, I'm gonna go back and I'm gonna read that error. You know, I've been programming for, a few decades, and it still doesn't make sense to me. It still is not automatic where I get an error and I read the error message, and the first thing you should do is read the error message to try to understand the error message. Well, did I do that? No, I didn't. Okay, so what this says is float object is not subscriptable. So I'm going, so then I don't know, is that your clue? It's not subscriptable. So why am I putting that there? Because that's for subscripts. So anyway, yes, right, that's right. So it's not subscriptable, but I don't see how this is even I don't see how this is even a problem then. But anyway, so that's what the right answer is. It was one of those problems that was just way too easy. But so let's just do the next one here. Embarrassing. Okay. Write a function swap. It swaps the fourth and the second elements of a list parameter. Okay, so I got a function here called swap. Def swap, and I'm gonna input some list, I guess. Some list, my list. That swaps the fourth and the second elements of a list parameter. Okay, okay. So there's a list parameter, and it swaps the second and the fourth elements. Can I do my list? I think I can do it this way. My list. No, I don't think I put parentheses. My list. The second and the fourth. So that would be like the second one is 3. I think I can do it this way. This is something you can do in Python, but you can't do this in any other language. My list 3 and my list 5 equals my list 5, comma, my list 3. Now, I think that it's supposed to look something like that, but I don't think I don't think you need to put parentheses around it. Let me just get rid of this thing. Let's see. Nope. 0, 1, 2, 3, 4, 5. 0, 1. Oh, did I? I did. Okay, so I think I got the numbers wrong. I oh all right. I don't know if this is I don't know if this is right, but x equals my list 3, my list 3 equals my list 5, and my list 5 equals x. It's x. So this is the same thing as what I just tried to do. But the trouble with this, of course, the trouble with this way is you have to use a temporary variable, but that's no big deal at all because the Python interpreter uses a temporary variable anyway when it's doing it. So I'm going to see if this is right, but I could have got the numbers wrong. I could have got the indexes wrong. So, but this will get rid of that trying to use that fancy statement. Okay, so yeah, I got the same answer, which means that what I was doing before was probably correct. So I need to replace 0, 1, and 2, 3. So 1 and 3. Aha, okay. 1 and 3. So I'm going to make this 1. I'm going to make this 1, make this 3, make this 3, make this 3. Is that right? Yeah, does this work? Okay, that works. Now, I'm going to see if my other thing worked. So take this here. See? So let's see if this works. All right, it does work. See? That's pretty cool. That's a pretty cool thing that Python can do. All right, what's next? Let's see where. Okay, so let's do functions with branches and loops. Well, this is We already know how to do branches and loops and stuff. See, this is that one. That's why this is. All right. So in this function, we got function here, you got some stuff inside, and we return something. So we're going to compute the fee. We got a sell price, got a bunch of stuff here. Start out with a base value for fee, and then based on whatever bunch of stuff we add to the fee, and then we return the fee. And so this thing passes in. Here it is. Calculate eBay fee. Passes in the selling price, and what is replaced is the calculation, which is going to be this value. All right, so numbers. Interesting. So what is so special about this? All right, cool. So this just says you can read in some numbers. You can read in some numbers, and then you can, separate what you want to do with them in functions to keep it more readable and so on. Read in 5 integers, you read some in, and then these are the numbers, and then there's it's a function of which outputs all the numbers, and then there's a function that just outputs the odd numbers, and then there's a third function that just outputs the negative numbers. So just like that. All right. Output of functions with branches and loops. Okay, so let's start. Okay. We're supposed to print. Okay. So we're going to start out by all right, we're supposed to print grade 1, grade 2, and grade 3. And the first one is the normalizing 49. So what does normalizing 49 do? I guess it makes it go in this range. Okay, so so what's the grade? 49 is the grade. 49 is the grade. Is the grade greater than the upper bound? The upper bound is 80. No, it's not. So go down here. Is the grade lower than the lower bound? No, it's not. 49 is not lower than 48. So then it returns the grade. Okay, so then it just returns 49. Okay, great. Okay, the next one is 82. So is the grade greater than the upper bound? Is it greater than 80? Oh, yes, it is. So we just return that, and that's what's printed. So return the upper bound. So we just return 80 then. That's what the upper bound is. And then the last one is 25. Is the 25 greater than 80? No, it's not. Is 25 less than 48? Oh, yes, it is. So now we just return the lower bound, which is 48. And that should be it. All right, good. Okay. Let's do this one. Okay. By the way, a trick with these challenge activities where we're supposed to print out what the program says. You can just run them. You can just if you want to, you can just run the programs and see what the answer is. Let's see if I got something here we can run the program with. Do I put that down here? This takes so long. Here, built-in program. This is in chapter 1, section 12 of chapter 1. So we can do is go back here, take this. This is cheating, by the way. Paste. Run. Oh, look. Enter your program here. 8. So this is the result. Copy this and put it here. Okay, now you shouldn't do this because this is cheating. But wait a second. Where is this? I don't see this here. Okay, I think it should just be -8. Oh, I know. I think it should just be that. All right. So why did it say that? Oh, because of this was here. That was there. Okay, anyway, but you'll notice that okay, as this textbook has evolved, these types of challenge activities where you're just supposed to type in what it says, they're becoming fewer and fewer. I mean, they figured it out. And in some cases, they actually they make it so this thing cannot be copied. I mean, so if you were to do it, you have to type it by hand. Anyway, let's do one more. Okay, this is the up. Num count equals 7. Print selected numbers. Num count. Oh, that's the input. Okay. Oh, that's the input, huh? Ah, interesting. Okay, let's see what happens. Four, 12, 8. Oh, well, anyway, so that's cheating. You shouldn't see, so that's great. So we cheated on this one, we got all those points. Well, big deal. This one you can't, this one you actually have to type in a program. So good, great. Define a function that with the parameter that, and if that is less than 3, print too small. If that is greater than 10, print too large. Otherwise, compute 6 times the bag of the ounces, and that equals seconds. Okay, so the solution is here. So the function is called print popcorn time. And the parameter is going to be something like bag ounces. I'm just going to say BO. And so if BO is less than 3, then print too small, capital T, too small. Otherwise, elif BO is greater than 10, then print too large. Otherwise, print, I better do some computation here. BO equals BO, I don't know, well, I can just use same variable times 6. BO equals BO times 6. So now it's 6 times bag ounces. So I'm going to print BO, comma, seconds. Let's see if this works. Put a colon someplace where I should not have. Oops, what am I doing? Oh, def. There we go. Def. Okay, that one works. Functions with branches and loops. Okay. Define a function, find priority. So that's a function, no, def. Gotta press start first, don't I? Okay. Find priority, def. And it takes one parameter. And what is that parameter? It's the number of project tasks to be completed. It takes one parameter as the number of tasks to be completed. So NT, number of tasks. And returns the task's priority. Okay. And so it is if the tasks count. Okay, that's what that is. Okay. The NT, if NT is less than 35, then am I returning the priority? Okay, I can just return 1. Elif NT is greater than inclusive, greater than or equal to 35, and no, and NT is less than or equal to 50, then return 2. Otherwise, return 3. All right. All right, let's see what the last one is. Define a function called this that takes 2 parameters. Outputs the first parameter. It outputs the first parameter, the second parameter, the number of times. Oh, outputs the first parameter, the second parameter, number of times, and one line separated and ending with a space. Well, I'm just going to start typing here. I don't understand what I'm supposed to do, but definition of output repeated. And it's going to take 2 parameters. And I'm just going to call it the, I'm just going to first, second. And on one line, separated with, okay, so that many times. So I guess I'm supposed to do like something like one line. 4 um, I in range second. I'm just starting guessing here. Print um, I end equals that. Let's see what it looks like when right? I assume we, all right, I assume we also do this. I assume we do that to print a new line. So let's see. Oh, oh, what did I do wrong? Output repeated. What did I spell wrong? Oh, it's not output, it's output. Output. All right. Nope. Let's look at the error message. Line 10. Sion? It doesn't know what did I mean? Oh, smart. It actually suggests to me an AI. All right, what did I do? Where's second? SECOND? SEC. Yeah, I'm not looking at what I'm typing. Okay, let's try this. Mm, man, I'm just doing a bad. All right, testing. Oh, what? Oh, what? So why is it not printing out what I'm supposed to be printing? Okay, so it reads in. Oh, I'm just not. I should be printing first, not I. See, that's just gonna print 0, 1, 2, right? Oh, I'm really getting this stuff wrong here. Sorry, all you people watching at home. Sorry, Mr. Chen, M. Chen. So we're still wrong, right? Still haven't gotten it. And this time it doesn't like, this maybe. I don't know. Stupid if that's right. Still didn't get it. I did get it. Okay, very good. Wow, wonderful. So this has got to be here, and this is the range. And you got to spell everything right. Okay, what's next? 6, 7. Okay, functions are objects. This just explains what I've said before. The functions are objects. Let's see if this works. Testing out lights. Not bad. All right, functions are objects, and so this just explains how the compiler or the interpreter treats when you define a function. You know, there's a name and some space associated with it. when you're defining a variable, there's a name and there's some space associated with it, and they're objects, and there's the rules about objects where you assign, you have a named object and you have another name, and you want to set the object equal to that new name, and there's rules about whether a new object is created or it's the same object with two different names, and that's just what this explains here. It's not really very important that you understand the subtle distinction between this. It's a little bit different in this language than it is in other languages. It's helpful to know this if you're ever being like tested or quizzed on Python, just Python itself. But as far as being a good coder and being able to code, it's not, I don't really think it's that important that you are clear on the distinction. All right, so, and this is common errors. I think we're going to probably source some. So wait, did we talk about this? Wait a minute, seems like we talked about this. Yeah. I'm sorry, people back home. We're down here. What did I just do? Yeah, so what happened is when I came back from the last one, I thought I was up here and I started talking about these things. So really, we're here. We just got done with function arguments. Okay, key argument, default parameter. Okay, so now we've just been passing arguments to functions. When you define the function, you got these parameters coming in, and there's an order to them. There's the first one, the second one, the third one. And so when you define the function itself, you want to make the order the same, but you might not, well, you don't have to have it be in that order. You can identify each parameter in the argument list. You can also have default parameters where if you don't specify a parameter, there's a default. And so that's what this section talks about. And it's kind of convenient. If you get into the habit of using these methods, the methods discussed in this section, to pass arguments to functions, it's kind of cool because it kind of makes it more clear. So here's an example. So you have this function called definition of a function called print book description, and the order of the parameters come in is first the title, then the author, then the publisher, and so on. Well, what you can do instead is you can say, when you're calling it, you can call it this way. You can say the title equals this, and the publisher equals this, and see, we're skipping author. But we put author down here, see, and then version and so on. So this is obviously much more clear. And this is unique to Python too. I don't recall being able to do this in any other language that I'm familiar with. But maybe you can, and I've just never used it. So there's that. So this is keyword arguments. And then here you can, this has defaults where you're going to send in an amount, a number of people, the tax percentage, and then the tip percentage. And then you can pass, and then, so here these are positional. So this 125 corresponds to the amount. And then we have tip percentage, which is over here. It's this thing. No, yeah. And then the tax percentage is over here, and the number of people is here. Okay, so that's out of order. That's passing arguments. Let's go on further. Oh, default parameters. This is what okay, so default, so here these are parameters or arguments we're sending to this date function. First one is the day, month, year, and then a style, okay, American style or European style. And so so we can leave the last one blank. We can leave style off because it has a default. Now, of course, it makes sense that anything you're going to have a default for has got to be on the end, you know, and uh, and stuff that you're not going to have a default for is going to be in the beginning because otherwise it wouldn't be able to keep track. So here we have so we could have this be defaults. Here it's the same function that we talked about up here, print date, but there's a default for every single one of them. So here, um, um, if we're going to use the default for, let's say we're going to use the default of this, then we have to use the default for this too, because we can't skip this and then expect the interpreter to know that this really is the style, the fourth one. See, so here we're skipping style, and then here we're skipping year and style, and here we're skipping, month, year, and style, and here we're skipping them all and using the defaults for all. So that makes sense. Uh, so those are mixing keywords and RE, but you can do that too. Mixing keywords and default parameters. And here's a challenge. Let's see. Okay, so we're going to show A, B, and C. So we're going to print A over B over C, or A/B/C. So we're going to print A, which is 2. See, I'm looking down here now. And ABC is the same as ABC. So A is, 2 slash 6 slash 5. 2, 6, 5. Is that right? Oh, amazing. All right, what's this one? Let's do the last one. Okay, so here, the first one is first we print B. And for the first one, B is the default because B is not defined here. So we use the default B, which is 2. And then we use the A. What's A? A is 1. And then we use C, and C is 7. Okay, so this is 7. And now we're going to use B, which is 5. And then we're going to use A, which is 6. And then we're going to use C, which is the default of C is 8. Right, is this right? Oh, we got to do the next one. Wait, what? Oh, no, never mind. Okay. All right, let's see if this is right. Okay, very good. Okay, you can do the middle too. Oh, here's another one. Got lots of them. Whoa. Okay, what's this one here? Okay, given that $1 equals 100 pennies, write a function number of pennies that takes 2 arguments, the number of dollars and the optional number of pennies. Number of pennies should return the total number of pennies. Okay, so it's going to take the number of dollars and multiply it by 100, add the pennies to it, and that's what it should return. The code reads 3 values from input and calls the number of pennies twice. Okay. Okay, so our solution goes here. So we're going to have a function called number of pennies, takes 2 arguments. def, number of pennies, and it's going to take, what's the D there? D supposed to be there? No, it's not. How did that get there? Number of pennies, and there's going to be number of dollars, and then another number of pennies. And the number of pennies is going to be optional. Okay, so okay. Okay, so I think the for optional, it should be 0. The number of pennies is optional. So if the number of pennies is not specified in the call of the function, then we're going to assume it's 0. So here we're going to return the number of dollars times 100 plus the number of pennies. That's what we're going to return. All right. All right. Okay. All right. What's this one? Okay. Write a split check function that returns the amount that each diner must pay to cover the cost of the meal. So it's a split check, and it's got 4 parameters. Boy, goodness. Okay. Oops. It's def split check, and it's 4 parameters. Bill, people. What are the 4 parameters? Bill, people, tax percentage, and tip percentage. How's that? And it's supposed to the tax or tip percentages are optional and may not be given when split the check. Use the default parameters of 15 cents for tip equals 15 cents. And tax percentage is 0.09 equals 0.09. Assume that the tip is calculated from the amount of the bill before the tax. The total doesn't matter if you add the tip first and then the tax, or you add the tax first and the tip. I don't think it matters. I think the total amount comes out to be the same. But anyway, yeah, because first you're multiplying it by a number, then you multiply it by another number, and multiplication is commutative, so it shouldn't matter. But anyway, so let's what we do is we we take we're going to return bill. Oh, okay, let's say I'm gonna create a variable T for total equals bill times, what am I supposed to do? Tip is calculated on the amount of the bill before tax. So tip, a bill times 1 plus tip is calculated first. 1 plus tip Okay, so that's going to be this will be the amount of the bill, including the tip. And then we're going to multiply that by the tax rate times 1 plus tax percentage. And then we're going to take that and divide it by the number of people. Oh, am I supposed to print out this cost per dinner and stuff? Oh, no, that's just one. Yeah, okay, one value. Where's that print out? Oh, here, cost per dinner. Okay. Uh, okay, so great. So, and divided by people. So I wonder if this is it. Let's look at the error message. All right. Unsupported format string past unsupported formats past what line is it? 11. 11. Split check. Bill people. Oh, I gotta call it someplace. No, here's where I call it. No. Split check. We've got a bill, got a people. I need to, no, I don't need.
What is that?
Hmm?
Is there is what is that?
Ah, you're right. Gotta return something, don't we? Let me just return this. What is return? Good question. What is returned? Yep, that's a good question. Not this. Okay, what am I doing wrong? Something's wrong with the okay, so I'm not um I need to I am confused. So why do I type something else in here? No, it's only up here that I first I do the tip, I do the tax, divide by the P. Hmm. Well, I'm doing something not right. See, I don't see where this doesn't seem right. Oh, maybe it's just text. Okay, right this tip, the tax. Calculate the amount of the tip and the tax, add to the bill. This is the Should be this. That's multiplying by the tip and adding it to the bill. And then this multiplies it by the tax and adds it to the bill. This divides it by the people. I don't. Oh, I think it should be an integer divide, but I just put that. I don't think that's right either. Am I getting the same results? Okay. 0.09 is the tax percentage. 0 is the tip percentage. No, well, this isn't right. Geez, I don't think this.
Oh,
I don't know if this is. I'm guessing. No. Hmm? Well, let's see. I'm gonna do the same thing. It's getting late. It's 3:15 already. Let me go back to here and go to chapter 6. Go to that. Which one was it? Is it 6:15 or is it? Yeah, this is 6:15. These are tough ones, man. Okay, here it is. Great. What's the answer? Huh. Right. Well, I don't. Oh, oh, this is the tip. The tip is. This isn't. The tip is calculated from the amount of the bill before the tax. See, so here, what this is doing is this is taking the bill and adding the tax, and then this is taking the bill and adding the tip, and then this is adding that. So, and what I did was I added, I did this first, and then I added the tax on top of this whole thing. Yeah, so that which is not what we're supposed to do. So which is not according to this thing. So let's do it let's do it how they said we should do it. Then I'm gonna say that the uh tip equals bill times tip percentage, and tax equals bill times tax percentage, and then total bill equals bill plus tip plus tax, and then I'm going to return total bill divided by people. Well, I don't go along with that, but all right. Well, I guess let's see. That's it. Do what else is chapter 6? All right. Well, we can cover this briefly next time. and then we'll move on to chapter 7. So are there any questions? All right, thank you for coming, and thank you in the audience here locally, and I'll see you next Tuesday. Thanks for watching.